In the diagram below, P, Q, R, and S are the vertices of quadrilateral PQRS.
We are required to show that PQRS is a rectangle. A rectangle has several properties, but to show that PQRS is a rectangle, we need only prove certain properties are true for this quadrilateral, and not all of them. A rectangle is a parallelogram with interior angles equal to 90 degrees. In other words, we will first show that PQRS is a parallelogram, and then go one step further to show that it is also a rectangle. The easiest way to prove that a quadrilateral is a parallelogram is to show that the diagonals of the quadrilateral bisect each other. In other words, show that the midpoint of both diagonals is the same point. We can also prove that opposite sides are parallel, or that opposite sides are equal, to show that a quadrilateral is a parallelogram, but working with the diagonals is by far the quickest method. So, starting with diagonal PR, the midpoint of this diagonal is the point, 7/2, which we will call M. Similarly, the midpoint of diagonal QS is the point, 7/2, which is the point M. And because M is the midpoint of both diagonals, we can state that the diagonals bisect each other, and therefore PQRS is a parallelogram. Because PQRS is a parallelogram, all other properties of a par now hold true. In other words, the opposite sides are parallel and equal, and the opposite angles are equal. All we need to do now is to show that one interior angle equals 90 degrees, which will then mean that all four interior angles will be 90 degrees, and therefore PQRS will be a rectangle. To show that one interior angle equals 90 degrees, we need to show that the product of the gradients of two adjacent sides equals -1. So, the gradient of PQ is -2, and the gradient of QR is 1/2. Since the gradient of PQ times the gradient of QR equals -1, we can state that PQ is perpendicular to QR, and therefore PQRS is a rectangle, since it is a parallelogram with interior angles equal to 90 degrees. If you are unsure about anything we have just done, or just want to refresh your memory, these concepts are covered in detail in the workbook, and in the online courses, the links of which have been provided in the description box below. Given triangle PQR with M and N the midpoints of PQ and P are respectively. MR and NQ intersect at K. T is the midpoint of QK, and S is the midpoint of KR. We are required to prove that MNST is a parallelogram. TS is a side of quadrilateral MNST, that joins the midpoint of two sides of triangle KQR, so we'll start in this triangle. T is the midpoint of KQ, and S is the midpoint of KR. So, KT equals QT, given. And KS equals SR, given. We can therefore state that TS is parallel to QR, the reason being, the midpoint theorem. By the same theorem, TS is also equal to 1/2 of QR.
To keep things simple, we will set QR equal to 2x, which then makes TS, x.
We can apply the midpoint theorem again, in triangle PQR. PM equals MQ, given. And PN equals NR, given. We can now state that MN is parallel to QR, the reason being, the midpoint theorem. We can also state that MN equals 1/2 QR, for the same reason. MN is therefore x units in length. Looking at quadrilateral MNST, MN equals TS, the reason is that both line segments equal x. MN is also parallel to TS, since both line segments are parallel to QR. We can now state that MNST is a parallelogram, because one pair of opposite sides are equal and parallel. If you like this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.